Okay, so let's put this together with what we've known and then see how this new information kind of helps us solve this particular differential equation. Okay, so on the left side, we still have our same process of finding the auxiliary equation. So that's m squared plus 3m plus 2. And then I'm going to factor, so that's m and m, and it looks like a 2 and a 1. So plus plus. All right, so I get solutions of -1 and -2, which tells me that my complementary solutions look like C1 e to the -x plus C2 e to the -2x. Okay, so let's talk about that 4x squared then. So what differential operator would annihilate the 4x squared? And that would be d3. So take the third derivative, and that should cancel that out. So I'm going to take the third derivative of both sides. So d squared plus 3d plus 2 equals 4d cubed x squared. And essentially that's going to make this side go to 0, the whole point of that. But then my auxiliary equation sort of changes its format slightly. It means we pick up a series of repeated roots then. So now I have solutions of m1, m2, and m3, all of which equal 0. And I'll just call the fourth and fifth solutions the original 2 that we threw in for our complementary form. Okay, so that then says that our general solution is going to have the format of C1 plus C2x plus C3x squared, and then those other two components that we found, e to the -x plus e to the -2x. And again, these two pieces right here come from our complementary form, so we're going to look at this piece. So our particular form, which just to make it easier to solve things here in a second, I'm going to, instead of calling them C1, C2, C3, I'm just calling them ABC. It's going to look like A plus BX plus CX squared. And then this process should look fairly familiar to us. So we're going to find the first derivative, which is b plus 2cx. And find the second derivative, which is 2c. And then we're going to go back into our original differential. So y double plus 3y prime plus 2y. And replace out the elements of the particular solution. So that would be 2c plus 3b plus 2cx plus 2a plus bx plus cx squared, all of which has to equal 4x squared. Okay, so then we can just start lining up elements of our exponents. So the only thing that partners up with the x squared, so I'm going to highlight that, is this guy right here. So that says that 2c has to be equivalent to 4. And then I want to look at all of my x terms. So that would say 2b plus 6c has to be 0. And then I want to look at all of the other terms, the constant terms. So I guess I'll just highlight those guys. And that says that 2a plus 3b plus 2c has to equal 0. All right, and then we can go in and find our a, b, and c's. So c would be 2, b would be -6, and a would be 7. So our particular solution would be 7 minus 6x plus 2x squared. And so our general is putting those two pieces together. So the complementary solutions with the particular solutions that we just solved for.